The thing that I want to talk about now is security since Java 8. So what's been going on in the platform since Java 8 was released back in about 2014, and generally how have things been going? The reason that I tend to talk about this topic is that I spent a pretty significant time in the space of security, dealing specifically with the security of Java applications and managed runtimes. From a long time ago, when I was an old circus performer, I did a lot of software engineering, writing code, building applications, doing a lot of design, incidentally right here in Chicago. Then I decided I want to figure out how to secure applications. I knew how to break into them. I knew things that could go wrong. So that's the time where I switched to do software security consulting. There was a company called Fortify. We did static code analysis. And then I figured out how to do that particularly well. So they said, do you want to come over and be the product manager of this? And my first response was, what is a product manager? I don't actually know what that is. Lo and behold, back in about 2013, for those of you who have been coding in Java a long time, you'll remember that the security of Java back at that time was not particularly great. So there was a large company whose logo is red, that needed somebody to come in who knew how to wrangle the security of software, and I said, that sounds particularly interesting. So I went and I joined that and assisted a lot with the security of Java 8. Then flash forward to now, I've done a lot in cloud migrations. I've done application security again with a company called Contrast. Now I'm Senior Director of Product Management for Azul. We provide one of the JDKs. If you'd like to use either of them, they go particularly fast. And with Fujay, I've just been hanging around in the community, the Slack, the different groups for quite a while. And I was working with everybody to do a jug tour on security last year. I went around and I talked about what are different attacks that are going on in the ecosystem. How do you defend against these attacks? And it was really interesting because security is a nice thing that's constantly going on, and there's just a nonstop stream of attacks against things. So I didn't need to build out a large play of like, how does this particular breach work? What goes on there? There was just one about every time that I went to talk to somebody. When we first started in September of last year, there was a large exploit going around against Atlassian Confluence systems. I'm going to explain how that works in a little bit. Then in December, there was Log4Shell. Incidentally, the shirt that I'm wearing right now, where you see the coffee cup with the skull logo on it, on the back of the shirt is written, "Live, Laugh, Log4Shell," because some of us spent so much time dealing with Log4j exploits that we just couldn't get enough of it. Well, fast forward in time a little bit, back in April, there was another one that was released, Spring4Shell. It was a way that you could compromise Spring applications because they had a defense that protected you from going from class to class loader. But when they introduced modularity, you could go from class to module to class loader and thusly exploit the system. Same thing back in April. There was a critical patch in the core Java runtime in Psychic Signatures where a JRE just became a little too gullible. Now, some of you might say, hey, that last one up there is from April. Do you have any new security exploits? Literally earlier today, while I was sitting in that chair, I was on this side of the room over there. I was just going through. I don't even look for these. It turns out that a friend of mine has been sitting on an about 2-year-old server-side template injection flaw in a Java templating framework called Pebble. So what you can do in this framework is if you give it a bit of instructions and you are able to control the template that it uses, you can just get that thing to execute a bunch of arbitrary code. So you can completely take over their server again. So anyone out there who is using the Pebble templating engine, please be mindful and go take care of that because there is an unpatched zero-day exploit in that is not overly complicated to do. And I always like to structure my talks in a series of patterns, a series of styles that we can go through to break it into sections. The first thing that I want to talk about today is how Java applications are being attacked. I want to walk through a couple of the exploits that are going on, both against the JRE or the applications that you use in your libraries, and look at the actual attacks that are causing that application to get exploited. Then I want to talk a little bit about what's happening recently in Java with the JDK or some of the libraries or the different patterns that people can use, and talk about some things that are coming soon. And then I always like to leave with defensive steps that you can actually do. So how can you harden your Java applications to make them a little more resilient against being exploited? Now, there's a lot of naysaying in security where people can say, oh, this is dangerous. Oh, there's a risk over there. Oh, you got to worry about these things. But in general, I think overall, the Java community, both the JDK leaders as well as the library authors in the community, are doing a pretty good job of staying on top of what's the risk to our applications, how do we defend ourselves, how do we get a regular patch cadence. And I think a lot of the security risk that affects Java applications has moved significantly less from the idea of there are attacks against Java itself, which occurred a lot in about 2013, 2014, a lot of 0 days back then. And it's more about what's the business case that you're using Java for? What are the libraries that you're using? How is your application structured in a way that creates weaknesses at integration points? And the risk has moved less from Java is risky and more to the concept of software is risky and Java lets you work with that. Now, a couple of the exploits that are going on, the last one that was in September of last year, it was really easy to attack Atlassian Confluence because what they were doing, they had a feature in there called Object Graph Notation Language that's just a domain-specific language where what their application would do is it would take various levels of the code that it was supposed to execute in OGNL from remote code, and it would pass those directly to the executor. So all you had to do if you wanted to break into an Atlassian Confluence server was to give it a query string. You see that's a series of Unicode elements up there in the top. And if you read it carefully, what you get is you can see they pass in class, they forename, and then they go after Java runtime. Get runtime, exec, and then they pass a command in there. So what an attacker can do is as someone who's remote, maybe they need to be authenticated, maybe they don't based on your Confluence settings, they could completely take over your Atlassian Confluence server by simply sending a URL string into it. That's generally regarded as not very good because anyone who can access your Confluence server, anyone who can read pages on it, can just tamper with their URL, those query strings, even get parameters, and just totally take over the server. There was a patch that was issued against that. The United States Air Force gave a very meanly worded statement at Atlassian that finally got that to be patched. But effectively, if you take remote input from people and you execute that as code, that is bad. That is the definition of a remote code execution exploit, and you should not do it. If you are running Atlassian and you haven't patched it in a while, you haven't patched your Confluence instance, it is a very good idea to do so because that was a remote code execution exploit. So in essence, the OGNL, that object graph notation language, it's a safe feature. There's nothing wrong with using OGNL in an application. The library is fine, but the problem occurs when you take remote data from people and you say that remote data is the code that I want to execute. Because what you're doing is you're giving remote users the ability to execute their own code on your server. Generally speaking, not a good activity. But let's move into Log4j. I know we heard a lot about it in the last presentation. There were a number of attacks against that. And you can look at a variety of the attacks that go on of people who try to put parameters against a web application. They try to submit get parameters, post parameters. Well, my username is JNDI. My favorite one at the time was people who photoshopped a Log4j exploit over on top of a car's license plate. And the reason that I think this is entertaining is a lot of organizations try to defend themselves using techniques like web application firewalls, various bits of web scanning. And those are fine. I don't want to tell you to not use those. But for those of you who develop Java software here, think about the way that you'd create a license plate recognition system. You would log everything that you saw. So if you were going through parsing a corpus of images, those are not web accessible. There's no way to filter that on the output because it's literally an image. But when somebody photoshops an exploit over top of that that says, JNDI:LDAP, and then they give you a site to connect to, your license plate recognition system is going to log that. And as a result of logging that using Log4j, your JRE is going to say, I know what I'm going to do. I'm going to go download the class at that location, and then I'm going to run that class as part of my logging. So that gives them the ability to totally control your server, and there were a pretty significant number of people doing different attacks like that back in December of last year. And the unfortunate fact is that you can still do a lot of those attacks today. You can still issue those Log4j payload exploits against a large number of applications, and unfortunately, they actually still work. So if you haven't patched your log4j, that's one of the ways to exploit it. I think it's funny because who wouldn't log their input from a car license plate recognition system and just totally take over somebody else's server? Well, what are some other attacks that are going on? How are people compromising different Java applications today? One of the major sources of flaws in the community for a while has been deserialization attacks, where you go, you give a JRE a class to deserialize, and then as part of deserializing that object and reading it back into its contents, the JREs will actually execute the code that's a part of that bundle. So what you get on systems that use deserialization is another ability to execute arbitrary code onto them. And the easiest way to do that against a variety of frameworks, there's a popular tool called why-so-serial that a number of people will use. What you do with why-so-serial is you can simply give it a command that you want to execute, you choose the framework that you know your target is running, and it will generate a payload that you submit to the application, and if the application deserializes that class, lo and behold, you get something like a remote shell on it. Well, Spring for Shell, that was not a deserialization flaw. That was a remote code execution exploit. What happened in Spring for Shell is they had a defense in there for several years designed to prevent people from exploiting the system. Very good. What it did was it prevented you from using a scripting language to go from an instance of a class to the class loader, because then you could get it to do things and you could get it to execute things. And if you use Java 9 or above, Java 9 has the concept of modules. So there was no behavior that stopped you from going from a class to a module. So essentially you just inserted an extra stop there on your path to exploitation, and you would say, thank you for giving me the class. I'm going to go and I'm going to get access to the module system here. And then once you had access to the module system, then you could hit the class loader. So years ago, they had placed a defense in there to defend against another exploit that stopped you from going from class to class loader. And once modules were introduced, all of a sudden there was a new path. But the thing was, nobody knew at the time that they had to add modules to that deny list and stop you from getting to those as well. So that was the exploit in Spring for Shell that occurred back in April of this year. Well, in the same time frame, it's not just the Java libraries that people are able to attack. There was one that was in the JRE itself. So CVE 2022-21-449, it's always hard to pronounce those numbers. Effectively, the JREs had a situation where if you were doing cryptographic validation with elements and someone presented them a certain type of certificate that had a certain number of the elements on it, those JREs would just become relatively gullible. And they would say, ah, that's a really good number. I trust that. I'm going to believe anything you say because you presented me with that certificate there. So if you have an application that was relying heavily on JSON Web Tokens, JOTs, or other cryptographic validation, it's a really good idea to make sure that you've patched your JRE to one that defends against this. That April critical patch update from earlier this year provides a valid defense against this that you can use. So all you have to do is upgrade your JDK. Now, there's a lot of these attacks, but so I always like to look at what's the common element, what's that unifying path that I can go through to recognize a way that I can deal with all of these different security vulnerabilities. And there's essentially two variants of these. The first is mixing data and code. That was Log4j, that was Spring for Shell, that was Atlassian, that's a lot of them. The problem that occurs here is when an organization mixes data and code and they say, I'm going to take that user input and I'm going to pass that user input into something that I'm going to execute and issue a control statement from. This is where you get a variety of other exploitation techniques, like SQL injection is another one. Essentially, anytime you mix data and code, you get a bad result because it gives someone else the ability to specify what your code is going to be and change your control statements. Now, another one here that we heard about in the past was vulnerable dependencies. I have my direct dependencies, I have my transitive dependencies. All of these older libraries that I'm going to use and incorporate, I've downloaded, I've built my system. If you're not keeping up to date with patching these vulnerable libraries, then chances are the vulnerabilities that are in those older libraries are going to nail your application. For example, today, if you're still using Log4j, it's okay that the Log4j group had a mistake in their product. It's okay that they made a mistake. It was a big one, but we all make mistakes. All you have to do is make sure that you're not using that vulnerable version of log4j anymore. If you are still using it today, you're still vulnerable. So the main thing that you have to do is upgrade to make sure that you keep them out. Spring had a mistake. Again, they fixed it. It's okay for applications and library teams to make mistakes, but if you sit there using the older version of the library, and you're using the log4j that's vulnerable, or you're sitting there using a version of Spring because you haven't updated it in about a year, it's probably a good time to update those libraries, especially when they contain a series of known CVEs. At the same case, Confluence, they had their remote execution exploit. What should you do? Update your version of Confluence. The main role is just don't keep using that old vulnerable version and sit there and say, oh, I haven't been hacked yet, nobody's come after me. But why does this matter to developers? And here I edited to give a compliment to Teresa for the talk that she did in the past, or the previous one. Effectively, why should I care? Why should I pay attention? I'm a software engineer. Why do these things matter to me? Well, in the case of Equifax, that was the example back in about 2017. They lost a ton of data in about 2017. Given that we're in the United States, chances are good you were a part of this breach. Almost everyone was. That breach occurred from an unpatched version of Apache Struts. They had it just sitting in there. It was known vulnerable, and they said, we're supposed to patch that. It would be a good idea to patch that. And they didn't, and somebody managed to break in. I believe it was a deserialization exploit in Struts as well. And lo and behold, the end result of that, beyond being hacked, beyond having to deal with dealing with a breach and dealing with the fallout, they were issued a fine in the amount of about $575 million, which is quite a bit. And they actually had to pay it. It wasn't one of those slap-on-the-wrist fines that sometimes go through. They actually had to pay that. Well, the other reason that this should matter to you is the Federal Trade Commission. Teresa, this is the thing that you were talking about. They actually have been active in software libraries in the past. They had a settlement with Oracle on Java security in about 2015. Things were written on that. They had a settlement with Equifax in 2017. They were the ones that issued that $575 million fine. And back last December, they literally issued a statement out there reminding people that they have the ability to fine you. So I love the fact that the FTC stepped out and said, hey guys, remember us? Hey, we know this log4j thing is going on. We're the ones that issue the fines. Did you know we can fine for that? So they literally said the FTC intends to use its full legal authority to pursue companies that fail to take reasonable steps to protect consumer data from exposure as a result of log4j or similar known vulnerabilities in the future. So basically what they're saying there is if you don't patch log4j, they're not going to go after you. But if you patch log4j, or if you don't patch log4j and you lose consumer data, they are really going to dig into you. But, you know, I talked with people a lot of the times, and no matter how much security risk I tell people, no matter how much I say it, I have a lot of people who sit there and they say, oh, that's not going to happen to me. I've already got my priorities. My management has set what to do. I don't need to patch these security vulnerabilities. Don't worry about it. You can still be exploited. That's fine. Well, you know, I got to test these vulnerabilities. I got to test my patches. It's okay. You're working on it. Doesn't matter. It's been about 2 years. Okay. Sure. Security becomes a priority, you know, you'll have to make time for it. There was a comment that somebody told me a while ago is security is not the priority until it's the only priority. If you want it to be the only priority, you are certainly welcome to do that. Don't let me stop you. Also, a lot of the guys who go out and attack these applications, they have automated crawlers just like search engines. Shodan is one of them. That has a whole bunch of mostly IoT stuff in the back end, but effectively you could just crawl around. You look for signatures that systems do. This is why if your version of Tomcat or JBoss or WebLogic or something tells its version, people could just search for that version, they find your server, and then they compare that server against exploits. It's really not that hard. All right, but what's been going on in the realm of Java security, and now that we've dealt with the way that things are attacked, how can we go, what's happening that actually gives us some capabilities to defend against this? Well, there's a couple things that have been going on that give us an opportunity of different things to do. Some of those are modularity, that's had a bit of a security impact and made things a little bit better. There's a release cadence where there's regular patches to the JDK that you're able to patch and implement and get upgrades that fix security cases. Also, the security manager was deprecated. That's the thing that most of you forgot was even there. It was designed for applets back in the day, and that thing is now deprecated. Doesn't mean it's gone, it means it's deprecated, and a couple new and different defenses. Now, the reason I talk about modularity first is this deals with what the concept of an attack surface is, which is someone who wants to break into an application, they have to find a way to get code to execute. So that's called the attack surface because it's the location of the ways that they can deal with your application. If you're a web application, you have a web attack surface. If you're a back-end data processing like a license plate reader, your attack surface is your image processing engine. And what I like about modularity is it gives boxes that things can go in terms of what that attack surface is. And now that applets are gone, I have significantly lower of an attack surface. But if I need to deal with a vulnerability class like XML external entity injection or XML bombs, which can explode the memory by referencing themselves, that's all inside the java.xml module. If I want to deal with JSP injection, if I'm just dealing with remote code that gets uploaded to my server and I execute that as JSPs, unfortunately a thing that I've seen, java.compiler. Meanwhile, SQL injection is a class of weaknesses that you can use to attack database applications that don't sanitize their input. That occurs in the java.sql module. And one of the reasons why I find modularity to be an effective defense, it's not an effective defense in itself, but it gives you an opportunity to deal with the modules themselves, such as removing them and making sure that they're not even there. Now, the release cadence, the big benefit about this, where there's a new critical patch update about every 3 months and a new major version about every 6 months, is it gives you an opportunity to plan ahead. You know what's coming, so if you're talking with a project manager, if you're speaking with someone in your management chain, you can talk to them and say, hey, in about 6 months, I'm going to need some time to do some compatibility testing because I want to upgrade our JRE. That's perfectly fine. Because what you get there is the ability to have a security patch where you can roll out and update your CVEs, or update your defenses against the CVEs by applying a new version. And effectively the way that this looks, either dev can update it or ops can update it, is you have a series of green dots there where each green dot is a critical patch update that fixes a lot of vulnerabilities. And you just want to keep pace with those green dots doing the best you can. You don't have to update every quarter. It's perfectly fine if you need a little bit of extra time, but stay as close to current on the green dots as you can. But every once in a while, there's an end of public life that goes on where, it's time to move from Java 8 to Java 11, or it's time to move from Java 11 to 17. Yeah, there's other ones in there, but this is what the majority of people are doing. And at that point, you have your choice of two options. You can either update your application to run on the next major version of Java, which isn't going to involve some compatibility testing to make sure that you run on it, make sure that you can support all the APIs, and that's that path there that moves you between the different Java versions. You can do that, which requires some development, or you can locate someone who still provides security updates to your older Java 8. Those are both perfectly fine activities. It's just a question of what you want to do. Essentially, if you say, my application runs on Java 8, so I'm going to stay on the very last end of public life release, that's generally not a good idea because any vulnerabilities that occur in that last end of public update for Java 8, you don't get the security patches, and it's a good idea to install the security patches because those are the things that defend against psychic signatures. Those are the things that defend against the various deserialization attacks. And elements like that, so you want to keep as far to the right on your security patches as you're able. Now, another thing that happened was the deprecation of the security manager in Java 17. Deprecation does not mean removal. If you use the security manager, you are still welcome to do it. You can do it if you want. If you're going to use it, if you say, hey, this is a really interesting thing, I forgot that security manager was there, it has the word security in it, security is important, therefore I should use it, it's really not a good time to start because it's going away. I wrote a couple articles about this in InfoQ. I thought it was particularly interesting to cover. It's just, what's happening now that there's a security feature going away. How does a security feature going away actually improve the security of things? And as I was talking with people about the security manager being deprecated and what that meant and how to deal with it, I was making some jokes that analogized the security manager to Radio Shack. Because Radio Shack is this store that you remember it from a long time ago and you thought that was a really good store, I want to shop there. But the truth is you never actually went there. You only went there because you found like an old radio in your grandpa's closet or attic or something and you thought, I'm totally gonna fix that. Once I get time, I'm gonna rebuild that thing, I'm gonna use it. Boy, if I ever get time to work on this, I'm sure gonna work at it. And that's what you go to that store for. The truth is nobody shopped there. I didn't go there. Nobody remembers the last time they went to a Radio Shack. But they basically sold a bunch of DIY solutions where you didn't actually want to use them. When you wanted a radio, you went out and bought a radio. You got one that actually worked. So the security manager in the same way was this really cool project that looked really good, that everybody thought they should use, and you thought, oh gosh, I should really use that. I don't use it, but I think I should. I don't shop at Radio Shack, but I like the idea. So it's a great store for someone else. And the reason that the security manager is not particularly effective is that it was built a really long time ago and defended against a different threat model that doesn't really matter today. So originally it was created for Netscape Navigator. When you had that applet plugin that sat there and you could get the dancing cartwheeling Duke who spun around and just did different things because JavaScript nobody really knew what it was back at the time. That's what the security manager was designed to defend against, was the concept of portable code that you didn't know if that code was safe to run on your machine. Well, the majority of applications now, they don't need to defend themselves against portable code. They need to defend themselves against the data that they process. So for me, it was particularly interesting. I got 2 articles that I wrote about the security manager. And it was interesting that in the several week span, I think it was like 6 weeks or a month or something, in between the time that I wrote those 2 articles, I met more people who wanted to talk about the security manager in that like 6-week time than I saw in about a decade of application security consulting with a focus on Java application. So nobody was really using this. And one of the reasons why nobody really used it is that securing an application, creating a policy, you need context for it. Like if I were to ask you now, if you're using a Tomcat, if you're using a JBoss, if I said, do you know what files that needs so you can create an allow list? I wouldn't know. I don't know what Tomcat's supposed to use. How am I supposed to get the answer to that? Deserialization is a risk. Do you know what classes your framework needs to deserialize? How am I supposed to know? Oh, is it safe to access the etc password file? Well, yeah, that answer is not a yes or no. Yes, it's okay to access the etc password file if you need it for the purpose of authentication, but no, it's not okay to access the etc password file if you're reading for files to serve to remote people over the internet. So the problem with a policy file was there was no real understanding and no clear roles in terms of whose job it was to actually create these, because it ended up in this no man's land of persona where neither the developer who built the application nor the operator who ran it knew what files it was supposed to ask. The person who built the application would say, well, I don't know where it's going to be deployed. You have to be relative to that system. And the operator would say, I know what's relative to my system, but I have no idea what you're supposed to access. So essentially, the security manager, if you went to use it on a back-end system, it relied on creating a policy file with answers that nobody had. Now, another one of my favorite things that's gone on is the creation of security events that get piped out to JDK Recorder. Flight Recorder is one of my favorite tools. There was a Twitter feed of vote for your best JDK feature a couple years ago. And me and a friend were doing like a poetry slam in favor of it. I wrote a lot of Flight Recorder poetry. It was real fun. If anybody wants to go look that up and get a blast from the past in terms of what we did at the beginning of COVID. But one of the nice things that's here is that it gives you a lot of good information that you can look at and see, because you can't secure what you can't see. So that element of, well, give me a listing of classes that I'm allowed to deserialize. How am I supposed to know what those are supposed to be? But in JDK Flight Recorder, you have the ability now to monitor deserialization events, which gives you the capability to actually monitor your JDK in a dev or production environment and see what those classes actually are. And the big benefit of this is it makes some of the other features possible. So I think in Java 9, there was something called serialization filters where you could create an allow list that said, I only allow the following classes to be deserialized. Now that was a really interesting feature, but the truth was when it came out, almost nobody could use it. Because if you said, oh, you can create an allow list of classes, what am I supposed to put there? Nobody actually knew what it was. So only once you created the listing and you got a recording of what classes you deserialized in an environment where you knew and actually tested your application, that was how you could create the allow list of saying these classes are okay to deserialize. So prior to the presence of deserialization events through JDK Flight Recorder, it was next to impossible to create that list. And if you need to use your serialization filter now, what I would do is test the application with a Java Flight Recorder in place, collect the listing of classes that I deserialize, and then I would base my allow list on that. And now I can actually use my serialization filter. But we don't want to just stick with different recommendations. Oh yeah, I went to this talk and all I heard was that different things are risky and that I can deal with them. I want to talk about some defensive steps that you can do right now if you go and are working on your application, or if you go later this week and you say, I want to defend my applications to make them a little more resilient. And the summary of steps that you can do right now is, number one, the easiest thing that you can do is maintain relatively in line with a patch cadence. Periodically update your JDK, periodically update your libraries to get the latest version of them. Number two is you can actually shrink the JDK to reduce the attack surface by taking advantage of modularity, because attackers who want to break into an application can't hack what isn't there. And then three, you want to apply some other JDK features. Now the patch cadence is relatively easy. It's conceptually easy to stay up to date with. It's not hard. I know it's work to actually do it, but about every 3 months, expect to update your JRE to the best of your ability. If you can't update on a particular 3-month time frame, if you have to miss one, that's okay. There are certainly ways to mitigate it and you can deal with it. But what you don't want to do is to lag and fall 2 patches behind, a year behind. Oh, I haven't updated my JRE in about 2 years. At that point, you have a significant amount of technical debt behind you that contains a large number of vulnerabilities. Now, in terms of monitoring libraries using the software composition analysis, periodically update those libraries. Set some kind of automated process that automatically updates them to the latest version, or something about 2.7 libraries behind current. But if you do that, then you have a cadence of, you patch the log4j, you patch the Spring4 shell, and you have a regular way of doing that. Because if you don't do that, if you're like Equifax, they had a very large breach that lost a lot of data. That breach led to a very large fine, and it also led to a short prison sentence for the CIO. He didn't go to prison related to the breach. He went to prison because he was doing insider trading on the breach. He knew that it would be bad, and he sold his stock, and that was considered insider information. So he was actually sent to prison and forced to pay some restitution on that. And the restitution actually exceeded the amount of money that he made on the trade, so that was a nice thing to see as just a regular trader. Now, how do you shrink the attack surface of your JRE? There's a tool in the JRE called Jlink that gives you the ability to actually remove older modules that you're not actually using. And the reason that I like doing this approach is that people who want to attack your application, who go after it using a variety of known exploits, they can't attack what isn't there. So if you use two tools, JDEPS, the Java Dependency Analyzer that can pick out which modules you're using, and Jlink, you can get a listing of the modules that you're using, and you can remove the modules that you're not using. So for example, if you're not going to use java.compiler, you can just take it out of there. That way, if there's ever an attack against java.compiler module, if there's ever a CVE in it, you don't even have it, so you can't be breached, and it's not even there. Same thing, java.sql. What's the easiest way to get rid of a SQL injection vulnerability? To not even have the SQL API in there at all. Because people can't attack libraries or capabilities that aren't in your application. You can use Jlink, generally combined with JDEPS, to simply take those older modules out. The other one that I like is jdkflight recorder. Excellent tool for monitoring the performance of your application. You can go in and get really deep inspections. You can figure out what the garbage collector is picking up, how often it's running. You can figure out how you manage your memory, where that's going, what's your I/O. You can get a lot of really detailed information from it. But on the security side, the best thing that you can grab is what are the deserialization events that my JRE has been doing. Because if you know what those deserialization classes are, you can create that allow list and only allow things that you know are safe to be deserialized. That will save you against getting nailed from a lot of deserialization exploits. Now, if you're interested in security, there's just a couple people who I think are particularly interesting. I'm up there in the top left. Yeah, so I don't tweet as much. I probably should use Twitter a little bit more. I focus on the Azul JREs and the JVM. I do a lot of Java security, Java analysis. I'm also one of the tech editors over at InfoQ in the Java queue. On the top right there, there's a guy, Ron Pressler, who was particularly intelligent, writing a lot in terms of what's going on with the security manager, why are those things being removed. And down in the bottom, I used to work with Arshan and Jeff from Contrast Security. Jeff is one of the authors of the Enterprise Rootkits paper that has a lot of techniques about how to take over different Java applications should you ever wish to do so. And Fujay, obviously, we all know that's a pretty good place to be. There's a nice community Slack where a bunch of people can talk. A lot of really good articles, so I'm glad to see a number of people here today just going through and talking it through. And so with that, I can kind of mill around. You'll recognize me by my Log4j shirt throughout the day. So yeah, your primary takeaways is update your JRE about every quarter. Make sure you're keeping pace with it. Deploy via Jlink. You can remove modules that you're not using and just record different security events that you're doing and get a handle on what your JREs are actually doing. Thank you very much. Oh yeah. We can do a Q&A if people want. I don't know what the status is. I didn't see have a time. Yeah, I want to make sure I don't take into the other presenter. Any questions on security or breaking into different JREs? I think it's a fun activity done well. Sure, what do you got?
Does checkmarks have some of this stuff built in already that we should use in the product?
Yeah, does checkmarks have some of the capability? So yeah, checkmarks is a security vendor in the application security testing space. Actually, I'll get back up here as I answer things. There's a variety of vendors that just provide different tools. They tend to do static analysis of software to find defects in your custom code and composition analysis. So they'll give you basically those two things.
Flight recorders more runtime?
Yeah, is Flight Recorder more runtime? Flight Recorder is focused on detecting what's happening in your production JREs. So the premise with Flight Recorder, it was created back in the old BEA JRocket days to get really deep performance metrics. So it will tell you about what your production applications are doing. So you can get production insight. And that's great on performance, but what I like it for is what is it doing that pertains to security? What files is it accessing? What have you deserialized? I saw a question over there. Yep. Yeah, what's the difference between jdkflight recorder and various tools like AppDynamics and New Relic? AppDynamics and New Relic are fine tools to use if you use them. Go ahead. They'll both give you pretty detailed metrics. I think jdkflight recorder, it doesn't need an agent, so it's already a part of the JDK. So if you're using a JDK that supports it, you might as well just take advantage of it. I'm sure AppDynamics and New Relic have invested a lot in their interfaces. They have done pretty well, so you're welcome to use either of them. Any other questions? In that case, I will make sure that we have a number of other speakers, and we will try to get everyone moving.